Okay, guys, now let's take a look at an example of a quadratic function. So a quadratic function means the leading coefficient of the equation, if we had the equation, would be 2. We would have x squared in the equation. It's called a quadratic function. The graph is called a parabola. So the graph of a quadratic function is a parabola. So let's talk about our x-intercept. Notice that this parabola crosses the x-axis at 2 points, and we're going to write those as ordered pairs. So our first, going from left to right, ordered pair of where this quadratic function crosses the x-axis is -4, 0. It also crosses the x-axis at 0, 0. Again, the x-intercept is when your y value is 0. Now let's talk about the y-intercept. This is where our graph crosses the y-axis. This is the y-axis. It crosses at 0, 0. The y-intercept is when x is 0. Now, our AOS, axis of symmetry, is the vertical line that runs down the middle of our parabola, and it intersects and divides it into 2 equal parts. The axis of symmetry is the line in which the right and left side of the graph mirror each other. When we write our axis of symmetry, we are going to write it as an equation. So a vertical line is the equation x equals, and it's wherever it crosses on the x-axis. So all these ordered pairs on this line, the x value is going to be -2. X is -2. Our vertex is the either minimum point in this example, or it would be the maximum point in this example. So our vertex is an ordered pair, so it's -2, -4. And I'm going to indicate that this is the minimum point of our function. Our domain are the x values of our graph. Our x values are -infinity to +infinity.